A Shottky diode is a semiconductor diode with a low voltage drop in direct connection. It was named in honor of the German physicist Walter Shottky. Shottky diodes use metal-semiconductor junction as Shottky barriers instead of p-n junction as in regular diodes. The main properties of Shottky diodes determine the area of application. They have low direct voltage drop and high response speed. Reverse recovery charge is almost absent. The reverse voltage of mass-manufactured Shottky diodes is limited by 250 volts. In reality, most Shottky diodes are used in low-voltage circuits, as reverse voltages ranging from 1 to several tens of volts. However, if you use silicon carbide substrates, silicon carbide (SiC), as the base, the operating voltage can be increased up to 1200 volts. Crystalline silicon carbide was first created in 1892. Then it received the name of carborundum. William Shockley, the inventor of transistors, said that silicon carbide was the perfect semiconductor. He was sure that by 1950 this material would completely replace silicon due to its excellent properties. Silicon carbide is a semiconductor with an indirect energy band structure. The width of the band gap varies from 2.4 to 3.3 electronvolts. This means a wide range of working temperatures. In theory, it's up to 1000 Celsius degrees, while in reality it reaches 600 Celsius degrees. It also provides for low leakage current of less than 70 microamperes at 200 Celsius degrees. The material is corrosion resistant at temperatures of up to 1400 Celsius degrees. It doesn't interact with any acids at room temperature. This explains why it is so hard to make semiconductor devices using this material. Silicon carbide has a high thermal conductivity, approximately equal to that of copper. Thus, it is easy to remove heat. Compared to silicon, the thermal resistance of silicon carbide crystals is 2 times smaller. Besides, this material has a critical breakdown field 10 times higher than that of silicon. The above-mentioned characteristics are responsible for the excellent property of silicon carbide Shottky diodes, which include the recovery time of main charge carriers at commutation is extremely low, almost equal to 0, a high breakdown voltage if compared to silicon devices, high working temperature up to 175 Celsius degrees, high frequency of switching up to 500 kHz. This allows decrease in the size of electromagnetic interference fields as well as the sizes of other passive components. And finally, silicon carbide allows decrease in excluding active or passive damping circuits. The key peculiarity of silicon carbide diodes is the low dynamic recovery back current. This is due to the gate capacity. The reverse recovery charge of these diodes is extremely low, less than 20 nanocoulomb. In bipolar silicon diodes, the main physical effects are caused by minority carriers. The latter increase the reverse recovery current as well as the reverse recovery charge. At the moment, high-voltage Shottky diodes are manufactured by several companies. These include the diodes of the STPS series by ST Microelectronics with the back voltage of 600 volts. Another example is the diodes of the CSD series by Cree, manufactured under the Zero Recovery brand.